In 1956, a Bell Labs scientist named John Kelly published a formula that, if applied correctly, provably maximizes your long-term wealth growth rate faster than any other betting strategy. It's used by everyone from professional blackjack card counters to quantitative hedge funds. And it comes with a trap that destroys accounts if you're not careful. The Kelly Criterion answers one question: given a bet with known probabilities and payoffs, what fraction of your bankroll should you risk? The answer is counterintuitive: not as much as you think, and definitely not all of it. Today I'll give you the single bet formula, the multi-asset extension, and the fractional Kelly approach used in real trading. The Kelly formula: F star equals P minus Q over B. P is the probability of winning. Q equals 1 minus P, the probability of losing. B is the net odds, how much you win per unit risked. F star is the optimal fraction of your bankroll to bet each time. This single formula encodes the entire trade-off between edge, odds, and position sizing. Concrete example: a fair coin where heads pays 2 to 1. P equals 0.5, Q equals 0.5, B equals 2. Kelly says bet 25% of your bankroll each flip. Not 50%, that feels right, but a losing streak compounds ruinously. Not 100%, one loss wipes you out. 25%, because the mathematics proves that is the exact fraction that maximizes compound wealth over time. Kelly maximizes the geometric mean, the expected value of the logarithm of wealth. G of f equals p times log of 1 plus fb, plus q times log of 1 minus f. Maximize G over F. The solution is F star at 25%. Notice, G rises to a peak at Kelly, then falls steeply. Betting more than F star produces lower geometric growth. Paradoxically, overbetting makes you grow slower and eventually go to zero. This is the Kelly trap: a winning strategy played at twice Kelly will eventually ruin you. At 10%, well below Kelly, the bankroll grows slowly but safely. At full Kelly, 25%, the bankroll compounds at the maximum long-run growth rate. At 50%, twice Kelly, growth is actually slower than full Kelly. The extra risk is not compensated. At 75%, reckless overbetting, the bankroll collapses towards zero. A strategy with a 50% win rate, played at 75%, will eventually ruin you. This is the Kelly trap. For a portfolio of n assets, the multi-asset Kelly maximizes the expected log return over all weight vectors W. In the Gaussian approximation, the optimal Kelly portfolio is proportional to the inverse covariance matrix times expected returns, identical to the Markowitz tangency portfolio. Kelly and Markowitz converge in the Gaussian world. Where they diverge is in fat-tailed distributions, where Kelly is more conservative because log utility penalizes extreme losses far more severely than mean variance does. Full Kelly is extremely aggressive and highly sensitive to estimation errors in P and B. A 10% overestimative edge can drive you to bet twice the optimal amount. In practice, traders use fractional Kelly. Half Kelly gives you about 75% of the long-run growth rate of full Kelly with dramatically lower drawdowns and variance of outcomes. Half Kelly is the professional compromise between growth maximization and risk control. Never use more than full Kelly. Applied to yield strategy selection, the Kelly fraction for each protocol allocation is proportional to expected yield minus the risk-free rate, divided by the variance of that yield. Higher yielding, lower variance protocols receive larger allocations. Smart contract exploit risk dramatically reduces the Kelly fraction. A negative 100% event has a log utility of negative infinity, total ruin. The Kelly fraction collapses to near zero for any protocol with uncapped exploit risk. This is why you must explicitly price smart contract risk before applying Kelly to any DeFi yield allocation. Kelly is the long-run optimal sizing formula, but only when your probability estimates are accurate. Use half Kelly in practice. Never use more than full Kelly, overbetting causes ruin even with positive edge. Always add a hard stop, Kelly is a ceiling, not a mandate. For DeFi, price smart contract exploit risk before applying Kelly. The formula is a ceiling, not a mandate. Next, risk parity, the portfolio construction method that ignores expected returns entirely and allocates purely based on risk contribution. Used by Bridgewater's all-weather fund. Subscribe. Quantitative.